Right, so we're going to continue looking at law of sines. Okay, same section as yesterday. This is just part 2. Okay, section 4.2. Okay. Anybody remind me, what's our formula for the law of sines? If you don't know all 3 parts, you can just give me one part. Well, Tiffany, can you give me first one part of the law of sines? Alex?
Sine of alpha over A.
There you go, one part, sine of alpha over A. How about the second part, Kelly? Sine of beta over B equals my third part. Yeah, John?
Sine of gamma over C.
Sine of gamma over C. Okay, so yesterday we went through an explanation of the first 2 parts. I showed you kind of where it comes from. We could have done the third part, but we held off on it. And when do you use law of sines? Like what kind of triangles do we have to use this on? Yep, so we got the 3 types. And what's kind of the big category? All those triangles have what? Or I guess you could say they don't have what in common?
90 degrees.
Yeah, you use this when you don't have a 90. Okay? You could still use this for a 90. Right? I didn't teach it to you because it's overly complicated for right triangle trig. It works, but you don't need it. We can use Pythagorean theorem and some other stuff. But when you don't have a 90, you have to use this. There's no other way to do it. Right, so as far as notes, there's really nothing new to explain. We're just going to try 2, maybe 3 examples. Probably 2 examples, maybe 2 word problems, and that's it. All right. I'm going to draw my diagram, and I want to see what kind of triangle this is. All right, so I've got A is 6. I'm going to put the angle across from it. B is 8. Put the angle across from it. We don't know C. We don't know gamma. All right, what kind of triangle is this if you describe it with the 3 letters? The S's and A's. Yep?
Side angle.
Yeah, side angle. All right. You know a side, and you know an angle. It's not the angle between the 2 sides. Okay, gamma is the angle between the 2 sides. We don't know that. Okay, is this the case where we got to check for multiple solutions?
Yes.
Yeah. All right, so I'd make sure you make your boxes big enough. All right, out of beta, gamma, and C, I have to find one of these first. Which one?
Beta.
Yeah, we got to do beta. Okay, if you've got a row that's empty, ignore it. Can't do anything with an empty row. All right, so let's set it up to find beta. Okay, Jess, can you give me 1/2 of what I'm going to put into that proportion?
Sine of 35 over 6.
Yep, perfect. Sine 35 over 6. On the other side, we're going to have sine of beta over 8. Okay, I already know I got to use inverse trig. How do I know that here?
Beta. Because you got to have a sine of beta by itself.
Yeah, we get the letter next to the sine function. Okay? Anytime you got that, you're going to use inverse trig as the last step. Right, so if you cross multiply, you're going to have 8 sine 35 divided by 6 equals sine beta. Okay, and Natalie, we just mentioned it, but how do I get rid of sine?
Inverse
Yeah, we're going to do inverse. Yeah, inverse sine. We do it on the right. Cancels out. We do it on the left. Okay, we had the question earlier, does it cancel out on the left? No, because of this extra stuff, the 8 and the 6. If the 8 and the 6 weren't there, then it would. All right. Also, in another class, somebody asked me, could I reduce 8 and 6? Sure. You could write it as 4/3. But really, what's the point? We're just going to type it in. Okay? Calculator doesn't care if we reduce it or not. Okay, so let's see what we get. Okay, so inverse sine of 8 sine 35. Make sure you close your parenthesis. Divide by 6. Okay, if I hit enter and I get an error, I'm done. Means there's no solution. If I hit enter and I get an answer, that means there's at least one answer, possibly a second. Okay. 49.886. Okay, off to the side, I'm going to write down possible second answer. What do we do with 49.886 to find what the second answer could be? Yep, subtract it from 180. I'm not going to write it in that box because I don't know if it's going to work yet. I'm just going to write it off to the side. Okay, if there's a second answer, it's 130.114. Does that second answer work?
Yes.
Think about the angle you were given and the one we just found. Do they add up to more than 180?
No.
No, so it does work. If you add them up, you only get 165. Right? So that's a second answer for beta. Okay, before I go on, does everybody see how we found 130? We just subtracted it from 180. And does everybody see why it works? All right, so what we're going to do is call beta 1. That's my first answer. And beta 2. Now, if we get two answers for beta, there's two answers for everything we have to find. Okay, there'll be two gammas, and there'll be two C's. Okay, it's not going to be harder, okay, than anything we've done. It's just going to be more of the same thing. You've got to do everything twice. Okay, so on a test, I wouldn't give you more than one of these, okay, because they take a long time. All right. What I'm going to do is circle in colors kind of what we're doing here. Okay, we're solving two problems at the same time. We're just putting all the information in the same table. Okay, this is one triangle. Alpha, beta 1, gamma 1. Those three red boxes all have to add up to 180. Okay, that's one triangle. Okay, my second triangle is alpha. That's used in both. Beta 2 and gamma 2. Those three green boxes also have to add up to 180. All right, so let's find gamma 1. Take alpha and beta 1, add them up. Okay, so I'm adding up the first two red boxes. 35 plus 49.886. Okay, and what do I subtract that from? Subtract it from 180. That's gamma 1. 95.114. Now, if I wanted, I could jump to finding C1. Okay, but what I like to do is, I just like to finish up all my angles first. Then I'll find my sides. Okay, what two angles do I add up to find gamma 2? 130. Okay, those add up to 165.114. Subtract from 180.
14.886.
Yep, 14.886. Okay, so now we got all our angles. Okay, and we're just about done. Last thing we got to do is get C1 and C2. Which row am I going to use to find C1 and C2? Think of rows without decimals. Yeah, row A. Okay, I know row A is correct because it was given. So let's write sine 35 over 6, just like we did to start. Now, to find C1, do you think we're going to use gamma 1 or gamma 2? Yeah. Okay, to find C1, that's part of the red triangle. That's part of the red triangle. And that's part of the red triangle. So there should be 6 red boxes up there. 3 sides, 3 angles. Right, so we'll write sine 95.114 over C1. Okay, and now we'll just cross multiply. So 6 sine 95.114 divided by sine 35. Okay, did anybody already have the decimal for that? 10.419? All right, thank you. Okay, and now our last step, we need C2. Which angle am I going to use to find C2? Yeah, 14.886. Okay, everything in the green boxes, that's the green triangle. Okay, so A is in both, B is in both, and then C2. Okay, those are the 3 sides of the green triangle. All right, so sine 35 over 6. Equals sine 14.886 over C2. Okay, you'll like the next problem because if this is a lot of work, the next one's hardly any work. All right, so C2 is 6 sine 14.886 over sine 35. And Chris, do you also have the decimal for that?
2.687.
2.687. Yeah, and that's as bad as they can get. It's the worst kind of problem you can have in terms of how long it takes. Okay, any questions on that? All right, so now what I'm going to do visually is just show you how I can take some lines and draw them. I'll keep 2 sides the same, I'll keep one of the angles the same, and I'll show you how I can get 2 different triangles. Okay. First thing I'm going to do is just take this triangle. I'm going to take this side and make a copy of it. Okay. So this and that are the same. All right, so I have one side the same. Next thing I'm going to do is make a copy of this. And I'm going to flip it. Is it still the same length if I flip it? Yeah, it's just a mirror image. All right, so now this side is the same as that side. So I've got a side, I've got a side. Now the last thing I'm going to do is an angle. Okay. I'm going to just draw this horizontal. So then this angle and that angle are exactly the same. Yeah, I can line them up and show you. Those 2 angles are exactly the same. So there's an example of 2 triangles. I've got a side, and an angle the same, but I can draw 2 different ones. Can't do that with any other type. Okay, if you gave me angle, side angle, or any of the ones we did yesterday, I can't do that. Only this type. Hey, any questions on that? Yeah.
So the 2 answer thing, is that only for side angle?
Yes. Yeah, the 2 answer, the no answer, the 1 answer, that's all side angle. You don't have to worry about that anywhere else. Okay, any other questions? Okay, even with what we learned tomorrow, you're not going to have to worry about that. That's only with this one type. All right, let's try this one. Okay, so this will be our last one where we have it set up as a table. Then we'll try a word problem or 2. Okay, without even making a diagram, I got a row with everything in it, and I have a row with nothing in it. The row with everything in it tells me it's log signs. The row with nothing in it tells me it's the case that I don't like. Could be 0, 1, or 2 solutions. Okay, let's start to solve it and see what happens. Okay, Hannah, can you set up one side of my law of sines?
Sin 50 degrees over 1.
Yeah, so we get sine of 50 over 1. And Dakota, what's going to go on the other side?
Sine of alpha over 2.
Sine of alpha over 2. Okay, I'm going to cross multiply. I get 2 sine 50 equals 1 sine alpha. Okay, before I even finish this up by taking inverse sine, I just want to show you what 2 sine 50 is. 2 sine 50 is 1.53. When we graphed sine last week, and you don't transform it, what's the highest and lowest it normally goes? The highest is 1 and the lowest? Negative 1. This is 1.53. I'm basically asking, when does this graph hit 1.53? The answer is, it only goes as high as 1. It doesn't. So let's finish solving it and see what happens. Okay, how would I get rid of sine? Inverse sine. Okay, so if you noticed what I just noticed, you could have already know the answer, but if not, keep going, and you'll see what happens. Try to take the inverse sine of 2 sine 50. It says error. Okay, domain. What you're basically trying to figure out, here's sine, here's 1.53. We're asking where these two graphs cross each other. Well, if I graph them, they don't. All right, so what does that mean? Yeah, there's no solution. Whether you want to think of it as a picture, think of it as getting an error, okay, whatever helps. But there's no solution for alpha. If you can't get alpha, what else can't you get? Yeah, you can't get beta. And if you can't get beta, you can't get the side across from it. This is an impossible triangle to have. Can't do it. Okay, I'm going to try to sketch it, and I'll show you what happens. But before I do it, what do you think is going to happen? If I try to draw it and I can't, what do you think it's going to look like?
You're going to have a space somewhere where the sides don't touch.
Yeah, I'm going to have a space or a gap that prevents the sides from touching. All right, so first thing I need is the side 1 unit long. Okay, it doesn't matter what I use for units. Let's call that a unit. Okay, then I need a side that's 2 units long. In other words, double that. Okay, so take that, and we'll make it twice as long. Okay, and put them together. All right, so now I got a side 1 unit long, 2 units long. Okay, A, let's see, was that that's the long side. Okay, what I've done is I already took my protractor and I measured a 50-degree angle, exactly. So all I got to do is turn this so it's exactly at a 50-degree angle. Okay. Now I can't turn that, right? I can't mess with that angle. I got to keep it at 50 degrees. All right, next thing, B, that was the shorter side. That was, actually, that's no solution. So B is going to be on the bottom. C goes right here. Okay, and I can't turn it unless I group it with something, which is kind of weird. If I can group it and then erase it, now I can turn it. Okay, so there's C. And now B, I have to keep it horizontal. I can make B as long or as short as I want. Doesn't matter. But I can't tilt it up because that would mess up this angle. And I can't I can't make this side on top any longer. So will this side ever reach the bottom? No, no matter how you turn it, it's never going to be long enough to reach. You can try shortening this. That's not going to help either. All right, so you can't sketch that triangle. Any questions on that? All right, so last two problems we're going to look at are word problems. Okay, these problems are in your book. Okay, this is on page 264. So if you just want to follow along as we're doing it, that might be easier. Otherwise, it's a little bit of writing to write the whole thing down. Okay. But if you want to copy it down, I will put it on the board. It's just a lot of writing. All right, so to measure the height of a mountain, a surveyor is going to take 2 sightings of the peak. All right, so basically what the surveyor is going to do is he's going to stand a certain distance from the mountain. He's going to take out his transit. He's going to measure the angle to the top of the mountain. Okay, then he's going to get in his car and he's going to drive back. Okay, and he's going to do the same thing again. By taking 2 different sightings of the mountain from different distances, he's going to be able to get the height. Okay, very, very easy using trig. Okay, the distance that he's going to drive back, he's going to do 1 sighting, and then he's going to drive back 900 meters, and then do the second sighting. Okay, the first time he takes a sighting, he uses his transit, measures the angle. It's 47 degrees, looking through his little device to the top of the mountain. Okay, what happens as you back up? Okay, think about like if I'm, like you say the lights right here, the mountain. As I back up from the lights, what happens to the angle that I have to look at to see the lights? Does it decrease or does it increase? Yeah, it decreases. Think about like a movie screen. If you're really close, you're looking almost straight up. As you back up, you don't have to look up as steep. All right? So as he backs up 900 meters, and now it's only an angle of 35 degrees. One thing we're going to do that just simplifies it a little is assume that the transit is level with the ground. Otherwise, if he's measuring all this from the height of his eye, we have to know the height from his eye to the ground. That part affects the answer a little bit. Obviously, when you're talking about a mountain, it's only like 5 or 6 feet from an eye to the ground. But we'll just assume that he's measuring it level with the ground. All right, so we've got all these words, all these sentences. What do you think a really helpful thing to do would be? Yeah, draw it up. Okay, one thing we definitely need is ground. Here's our ground. Okay, and we need a mountain. All right, let's put in our mountain. There's our mountain. Right, we also need to mark the 2 spots where he does the sightings from. We don't know how far he is from the mountain. We never need to know that. Let's just say he's here at one point, and then he's here. And how far back does he drive between the 2 sightings? The sightings are 900 meters apart. Okay, what I'll do is I'll draw the sightings in as dotted lines. So there's 1 sighting. Okay, and the first time he takes a sighting, it says the angle going up to the peak is 47 degrees. Okay, I'm going to do the same thing one more time. Okay, and drive back 900 meters, take a sighting again, and this time, what is it, 30? 35? And our goal is to find, it's a little thicker than I needed, the height of the mountain. Okay, that's the height. H. So that's what we really want to know, H. All right, first thing I would focus on is this triangle right here. Okay, that triangle in green. There's one more thing I can find out about this triangle in green that I'm going to need. This angle is helpful, but it's outside it. How could I get the angle inside?
Subtract 180.
Yeah, I could just subtract from 180. All right. 180 minus 47. That tells me this angle inside is 133. And I can now do one other thing. I've got this angle. I've got this angle. I can get this angle up at the top. Okay. How would I get this angle at the top? Yeah, add 35 to 133. Subtract it from 180. Okay, so we get 12. Any questions on that? All right. Now, my goal, I really want to know this side. Because if I can find this side, and I know this angle is 47, I'll have a right triangle right here. And then I can find the height very easily. Okay, we can go back to old stuff we know. Okay, Pythagorean theorem, SOHCAHTOA. But I don't have enough information in this blue triangle. I've got to find this side first. Okay? Which I can do. Let's call this side x. Okay, and let's set up our law of sines for that green triangle. All right, so this time I don't want you to think of it as A, B, and C, or alpha, beta, and gamma. Think of it as sine of an angle, divide by the side across from it. Sine of an angle, divide by the side across. So is there anywhere here that I have an angle and the side across from it? Mm-hmm. Yeah, which one? The 12 and 900. That's my row with everything in it. Sine of 12 over 900. Okay, and now I want to find side x. So I got to use the angle that's across from that side. What's the angle that's across from side x? 35. Now we could use A, B, or C if you want. I used x. Okay, and now solve for x. So it's going to be 900 sine 35. Divide by sine 12. Okay, let's see what we get for x. All right, so 900 sine 35. Okay, if I want, I can do that part first. That's the numerator. I'm just going to take it and divide by sine 12. Okay, so x is 2,482 point, let's just round it to 0.9. 2,482.9 meters. Okay, is x the height of the mountain? No, but now I'm going to look at this triangle in blue. Okay, I'm going to draw it right here. For the triangle in blue, side x is really the what? Yeah, I just found the hypotenuse of that triangle. Okay. 2,482.9. And how big is this angle in the lower left? It's 47. That's my height. That's the height I want to find. All right, so I've got an angle, a side, and a side. I just have to figure out what the names of these two sides are. All right. H is across from the 47. Is that opposite, adjacent, or hypotenuse? Opposite. 2,482 is across from the 90. That's hypotenuse. which trig function has opposite and hypotenuse in it? Sine. Okay, so the sine of your angle equals opposite over hypotenuse. Okay, so the part that we learned this week is done. We did the law of sines. Now the second part of the problem is kind of tying in something we did before. You could actually use law of sines again on this part. I didn't because it's a right triangle, and we have a shorter way to do it. That's what I'm doing. Okay, and my last step, how do I get that 2,482 on the other side? Close. I like the idea of multiplying, but just multiply by the number. All right? You don't have to flip. So your final answer is 2,482.9 times the sine of 47. Okay, let's see what we get. Sine of 47 times 2,482. All right, so it should come out to 1,815.9. Okay, definitely a little bit of a challenging problem because you had to do two things. You couldn't find the height you wanted right away. You had to find something else first. Okay. Any questions on that one? Okay, what I would do on a test, I'd help you out with the diagram a little bit. Okay, so if you had trouble with that part of it would already be drawn for you. Probably most of it. Okay, there will be one question similar to this on the test. Either this one or the next one. All right, so let's finish up with our last problem. Okay, last problem is about Coast Guard stations. Okay, this is page 264. Number 7. Okay, like the last one, it's a ton of writing. Really, all we want is the diagram. Okay, so if you want to copy it down, you can. If not, it's right in your book. All right, so we got 2 Coast Guard stations. Okay, the 2 Coast Guard stations are called Zulu and X-ray. And the stations are 120 miles apart. A ship sends out an SOS signal, and each station hears the signal. Each station can tell what direction the signal is coming in from, but if all you have is a single station, all I could tell you is the signal's coming from that way. All right? I don't know if it's right in front of me. I don't know if it's 50 miles, 3,000 miles. All I know is it's that way. But if we have another station that says it's coming from that way, basically what we can do is figure out where the 2 lines would cross each other, and that's where the boat would be. They used to use this idea sometimes if they had fires. They used to have fire towers set up. And before we had more sophisticated technology, basically if 2 fire towers, one guy could say, you know what, I can see the smoke coming at an angle of 30 degrees from my tower. And then maybe another guy 200 miles away says, I see the same fire and it's at an angle of 50 degrees to my tower. Well, as long as you know where the 2 towers are, and they each know the direction to the smoke, they can tell a helicopter or someone exactly where the fire is. So it's kind of similar to that idea too. All right, so the SOS goes out, and the station Zulu picks it up at a bearing 40 degrees east of north. Okay, if you don't know what east of north means, I'll show you, and I'd help you with drawing that on a test. Basically, east means to the right of due north. Okay, and we also have a bearing from station X-ray. Okay, the bearing here is 30 degrees west of north. Okay, which that means 30 degrees to the left of due north. Okay, basically, we just want to figure out where is the boat. Okay, how far is it from each station? All right, so again, all this writing is great, but what's going to help us simplify all this stuff?
Table.
I'm not going to use a table here. Yeah, just make the diagram, okay? Just make a diagram. All right, so first thing I'm going to do is I'm just going to draw my shoreline. Okay, so if you copy anything down, I would just copy the diagram. Okay, on the shore I have 2 Coast Guard stations. 1, 2. Okay, and somewhere out here, I have a boat. Okay, there's my boat. Okay, now they told me which one was to the west, so I just have to make sure I get this right. It says Zulu is west of X-ray. Okay, so let's call this Zulu, X-ray. Maybe dots would be less confusing. And what's the distance between the 2 stations?
120 miles.
120 miles, okay, between the 2. Right? And the boat is sending a signal to each station. Okay, I'll draw that in as a dotted line. Boat sends a signal to that station and a signal to that station. We don't know if the boat is exactly centered between the 2. Doesn't have to be. Okay, and just make that a dotted line. Okay, that's the signal. Dead dot. Okay, now the bearings we have for the signal are from due north. Okay, what direction is north? Yeah, if you think about it like flat on this page, north is up and down. So what I'm going to do is draw in a line that's perfectly straight up and down. Okay, so I can mark north. Okay, I'm going to do the same thing on the other side. Okay, just marking north. Perfectly straight up and down. Okay, now I have to go back and read what it tells me about these angles. This is north. All right, it says, ship sends an SOS signal. The call to station Zulu indicates that it comes in 40 degrees east of north. Here's north. This angle is 40 degrees towards the east. Okay, if you're not familiar with compass, east is that way, 40 degrees east. Okay, so if this angle is 40, what's the angle on the inside? 50. Because together, that's a 90. All right, let's see what the other one says. Okay, the call to station X-ray indicates the bearing is 30 degrees west of north. All right, so this call is coming in 30 degrees west of north. Okay, that's north. It's 30 degrees towards the west. So what's the angle on the inside here? 60. Okay, now we have our triangle. Okay, we can forget about the word problem. Just focus on this. Just look at that red triangle. Angle, side, angle. Okay, that's one of the problems you can use law of sines for. Okay, I've got the 50. I've got 60. What's this angle at the top? And how do we know it's 70? Yeah, they all got to add up to 180. All right, let's call this side A and B. Okay, they want us to find A and B. That's the distance the boat is from each station. Right, so we're going to have sine of an angle, divide by what's across from it, and sine of an angle, divide by what's across from it. Do I have an angle and a side across from it that I know? Yeah, which one?
120.
Yep, so you're going to use that one twice. That's like your row that's got everything in it. And how would we find A? What angle?
Sine of 60 over there.
Perfect. Okay, going to set it up one more time. Sine of 70 over 120. Now we're going to find B. Which angle do we use for B? 50. Sine 50 over B. And now it's just the tedious part. We've got to type all of it in. All right, so for A, we're going to get 120 sine 60. And divide by sine 70. Okay, so the distance here is 110 miles from Z, or whatever A is, from Z to the boat. 120.6, 110.6. Okay, and the other one, I'm going to do 120 sine 50. Okay, and I'm going to divide by sine 70. Okay, so the distance there is 97.8 miles. Okay, so we answered everything they wanted. A couple things that we didn't account for in this problem is most of the time if there's a boat in the ocean, let's say its engines aren't working, GPS isn't working, all it's got is its radio, is the boat going to stay perfectly still? No. If the current is pushing the boat at, say, 20 or 30 knots, that's what they use to measure the speed of boats, and you're trying to rescue the boat, what they'd have to do is they'd have to fly, if they had a helicopter, to where the boat is going to be. So if it's going to take them 4 hours to get there, maybe the boat is going to move 200 miles in 4 hours. So they need to fly to where the boat will be, not where it is now. If they fly to where it is now, the boat's going to be gone by the time they get there. All right, so there's some other things you need to take into account. Also, you might say, well, B's a shorter distance, so let's just send a rescue from B. Well, maybe B only has a boat and A's got a helicopter. Okay, helicopter can probably go faster. So even though it's farther away, maybe station A's got faster equipment. Or it's drifting towards A, yeah. Maybe by the time A gets there, it's going to be a lot closer. All right, so there's common sense factors to take into account. All right, so homework tonight, okay, it's page 267, 29 to 35 odd, 39 and 43. Okay, and that's it. Okay, so we'll look at that tomorrow, and tomorrow we'll also do our last section of the week, and then Thursday will be a review day.